What's up, guys? How's life going on these days? How's our DIY hobby? Welcome back to the Arduino project, the XMI with the A3C shield. And in this video, let's take a look at the real world application of our project. And let's go for that. This is my diagram, which is the traditional analog power supply of our DIY made power amplifier. Apologies if my drawing is not that very well, but I would like to go through the very start from the left side to the right side of this block diagram for students and starters in the audio power amplifier. So we have our plugin here. That is the, let's say for the Philippines, it's a 2 pins and we have 220 volts AC. That is 60 hertz in Philippines and 50 hertz in China. And we normally have the fuse in here, fuse F1, and then we connected directly to the primary of the transformer. This is a toroidal transformer. There is a switch SW1 here to power on and power off the power amplifier. We have a center top transformer here, the secondary, and what it does is that from 220 volts, it stepped down to 22 volts. The output of the transformer is 3 wires with this is the center top and the output one, which is 22 volts from 220 to 22 volt AC, and the output 2 is also 22 volts. And I have here a PSU board, that is a power supply unit board, which is comes with the rectifier and bulk capacitors. And what it does, this board, is that from the 22 volt AC, it will convert that into a DC. And this some waveform in here, that's for the plus side. And this one in here is the negative side. So we will have then a split supply in the DC, that is the plus 5 volts, that is the minus, and this one is the common or the GND. And that is pretty easy for an analog power supply. What we wanted to do actually to power on and power off with this toggle switches here, SW1, and when we toggle that one, my diagram is not fully correct, so I'm going to add the on in here. So initially that is off, which means to say the amplifier is off, and this LED here is not lighted. When we toggle the one, then the power supply will be active, and there will be current through the LED, through these limiting resistors, and then this LED will light up. If we're going to put the SW1 and the LED in our front panel, assuming that we design in this way, then that is the toggle switch, power on and power off, and the LED is in there. And sometimes when we do DIY power amplifier, we have a kind of inspiration, and probably the girl that inspired us by that time, her name is Donna. Probably we already forget Donna should be double N, Donna. And well, that's okay anyway. The real stuff right now is that it's the one that inspired right now to do our Arduino HMI project. So showing that our objective is to change this SW1 and the LED in here into a more novel power on and power off the amplifier. Let me redo it and like doing this way. And this is the magic. And there you go. I got my updated drawing with the Arduino HMI board in here, the relay, and the switch SW1. What I've done is to replace the toggle switch in here into a relay controlled by the AMPduino-mMm board, the A3CS, of course with the Arduino Uno as the main board, and I added a switch one in here with the LED inside. So when I press SW1, LED will turn on, relay activated, and the 220 volts will be applied in the transformer, and the PSU board will generate the split power supply plus or minus the volts. And the way I implement that into the front panel of the power amplifier, assuming that my inspiration right now, I mean, you heard the Arduino in 2025, and the girl that inspired you is now Linda, from Donna to Linda. And this is how it looks like on the front panel of an amplifier. You get your SW1 in here. This is the switch S1 to power on and power off, and also included inside is the LED. As simple as that. Power on, the LED one will turn on, and power off, the LED will turn off. That is a good achievement because you make changes to your power amplifier front panel, and also your inspiration change from Donna to Linda. There is always an improvement in our life, and that's really the real word. This is life anyway. This is life. Let me put this into a real world demonstration with my analog power supply in here. This is the one that I designed for the project DNY40. That is an amplifier in cooperation with Mr. Danny and Mr. Rochi. Mr. Danny, by the way, is from Seattle in the USA. Good DIYers and designers. Before we're going to start the test, let me emphasize the importance of safety when we are working with a little voltage like the 220 volt AC. This is a little weapon, no, not a little weapon, this is a little voltage which need to take care of it. Be careful of this when you are working on it. Having said that, this will lead me to discuss about safety matters. I had to make use of this so-called safety bulb in here, which is traditionally but effective one, wherein you're going to insert a bulb in here, and that's your outlet for testing. For my personal use, I need to put a switch in here and put this one in front before your unit under test. And this is very effective actually in case there is any problem, and you will not going to burn your unit under test. So we have here the Arduino HMI right now. You can see this relay, this part in here. This is the normally open, and that one is the normally closed. So I'm going to make use of the normally open and connected that into the 220 volts line. I'm going to put the masking tape. This is a little voltage, so I need to protect it. I go that way and put it that way. You know why? So we have some protections that in case you accidentally pull down, then you can actually make it sure that that will not gonna happen. So you see how did I do that? So in accidentally pull that one, it's not easily be dislocated. With all the discussion that we have right now, with the highest priority on safety, I would like to show you in the real world. So this is the bulb. That is the bulb in there, and this is the outlet and the switch. It is in here. This is the switch, and this is the outlet. And I'm going to plug that into the 220 volts later. And then the setup, the transformer in here, transformer, the fuse is in there, and then the wires going into the power supply board, and this is the Arduino HMI, and I'm monitoring the output voltage of the PSU board. I put that one into DC. This is on auto range. Let me put that one into better viewing angle. So there you go. Put the alcohol over there, and the setup is already been verified, and we can go with the test right now. What I expect is that these capacitors in here, they are fully discharged, and that is a 4,700 microfarad multiplied by 3, about 14,000 microfarad, and initially they don't have any charge, so the inrush current we should see on the bulb, which is will glow like that. That is my expectation, and we can see DC voltage in here at this voltmeter, and here you go, power it on right now. Here is my hand, and push button in here, and there you go. You can see the inrush current actually, and now the capacitor is charged, and we get plus 32 volts in there, which is I just hook up that into the plus side of the split power supply. So if I'm going to turn it off right now, you can see that the voltage in here is keep maintained because there is no any load. You go down to probably 0 volts, but it will take longer time because there is no load right now. So if I'm going to power it on once again, there will gonna be no inrush current because the capacitor has been charged, as you can see in here. So 3, 2, 1, and take a look at the LED. There is no any inrush current right now. Well, simply because the capacitor has been charged up. Speaking of the inrush current, by the way, and that comes the soft start, which is another feature of the Arduino, but we're not going to demonstrate it right now. So it has been proven that basically the Arduino HMI right now is working with just the LED in here. We don't have yet the LCD. We will come to that in the future, but I'd like to stress in here, if you wanted to implement it right now to your power amplifier, and you might question that this relay in here, this relay is just 250 volts. That is 10 amperes, and it's too small. Probably you have a doubt on that. And the things you can do is get another relay. This one is a 2 relays. And if you are not satisfied with this one, you're gonna satisfy probably with this bigger relay, which is 30 amperes at 220 volts or 250 volts AC. 30 amperes at 250 volts. This is a dedicated relays, by the way, that I made for my personal project that requires a high power. Well, with your knowledge on a circuit driving relays with the logic 1 or logic 0, you can actually implement a similar one like this. I think this is a nice idea right now. What do you think, guys? What do you think? If there is no questions, clarifications, that means it signals me to continue my work in here, this one in here, which is the HMI right now with the LCD. If there is a questions, let me know on the comment down below. So guys, this is the end of the video, and from my apartment here in my job site here in mainland China, bye for now, and see you in the next video. Have a good day, guys. Whatever you're doing, enjoy the hobby.